Welcome to the Databricks Skill Builder series. We're glad you're here.
Hey everybody, so glad you're here. Just wanted to give you a quick sneak peek of what we're hoping to cover today. Arthur and Robert are going to go through the back end of this piece. How do you create quickly in Databricks a chatbot that's powered by Databricks that actually interacts with your endpoints? So here you can see asking about a job, canceling a job, running a job. Very cool. Stick around to see how to do this yourself.
Hey folks, Arthur Dooner, Specialist Solution Architect here with the LML team at Databricks today. I want to highlight one of my colleagues, Robert Mosley. Robert, if you wouldn't mind introducing yourself real quick.
My name is Robert Mosley. I'm a solutions architect here at Databricks. I've had a long history with data warehousing, with data governance. I had sort of technical exploration or tinkering with LLMs, starting a few years ago. And when ChatGPT was released, it put me in a spot where all of a sudden everybody was interested in LLMs, and I had a base understanding of how they worked, how to fine tune them, things like that. Because of that, I've been able to really sort of accelerate adoption around the use cases with LLMs. I've been very interested in the concept of compound AI, particularly around agents. And so a lot of my work has been around accelerating agent adoption and building out a framework around that. That's what we're covering today.
Thanks, Robert. So how we're going to run through this is we are going to quickly introduce the concept of what is compound AI. Then we will transition to talking about examples of compound AI systems and how you can think about designing them, right? And then we will introduce Robert's Agent Studio demo, and he'll walk us through that and how it quickly accelerates teams to be able to build these systems of solutions extremely quickly, right? The time to value, time to like first token, right? And I say that not in a sense of like how quickly your system went from an invocation queries and starts getting a token, right? But I mean in a sense of how quickly your team can build its first system, right? That life cycle has historically been months, weeks, at best days, right? To build these RAG systems, spin them up and deploy them somewhere. A lot of dimensions of thinking and effort for individual practitioners to build these. What an agent studio does is it recognizes that each of these are tools in a broader system that we can connect to and have a central mandate or prompt around, right? Such that we can then use this to quickly build and test these systems. So let's back up a little bit. When we think about agents, we cannot talk about agents without the lens of compound AI. What is compound AI? Broadly, it is the recognition that generative AI systems do not exist in a vacuum. If they existed in a vacuum, having a RAG solution would be the end of the story, right? We'd be able to say, okay, this is great. We're really happy with this. But there are layers of complexity that are introduced over this, right? How do we make sure we maximize accuracy? How do we make sure we have good governance over these systems? How do we chain these RAG retrieval systems with actions that these systems can take to send emails, to promote models and other tools from one layer of production to another, right? Or one layer of like dev stage prod, to another. How do we make these systems do a lot of the actions dynamically for us that we would have to do manually ourselves before? And just having a retrieval mechanism and some generation doesn't get you there. Compound AI, these systems involve a lot of different AI tools, computer vision, language understanding, audio transcription. And recognizing those are pieces of an overall deterministic, and cognitive architecture. How does this fit in? When I think about these systems, I want to map your understanding from RAG to this compound process. And there are 5 key concepts that I want to shift your thinking in. And this is around tasks that you might take in a RAG system now fit in as overall workflows as we build out each component. When you think about retrieval in a system that takes all of these vectorized data sets and returns the most relevant documents, we instead recognize retrieval as just one type of function or tool, right? The questions and answers that we ask end up shifting to be intents and routes rather than just saying, hey, what is our company's policy for PTO? And getting a simple answer from a knowledge base. It's, if I have any more vacation time, help schedule me for February 25th. It's saying, okay, we need to look up the policy. Is this person in compliance with the policy? And then action on one of these specific paths, i.e., designing this route and approving them, hopefully, for vacation. When we think about metadata that we use to help narrow down the window of context and documents that we have to retrieve in a RAG system, we instead view that as a parameter on a path that a function or tool utilizes. And as we build out generation, i.e., have the LLM generate new tokens, it is not simply generation around a context of an individual task, but reasoning around all of the tools that the LLM has available to it, and then returning that reasoning to say, okay, let's use this tool, let's use that tool. Now we have all of this additional context from these variable tools and returning an overall picture, a more complete response that this LLM has reasoned through. So we think about how these systems are built, right? A relatively simple concept here maps to same top level, we receive a prompt, then we might prompt expand, which is a type of prompt engineering, right? Where we say, rephrase these prompts in a few different ways, such that we could capture any potential intents out of them. These intents are one of the most core pieces of this system. The intent is a task or set of tasks or pathway through a system that we as an LLM recognize that we would want to solve. And those intents are either extremely clear, whereupon there are defined paths to solve, asking a simple question with RAG, very clearly go to this knowledge base, compare this question to the set of documents, return, right? Straightforward pathways through systems that are accelerated and performant, right? People get their answers very quickly. Then, when the intents are fuzzy or multidimensional, and we might not have built out that accelerated path through the system, that's where we really need an agent to recognize, given these tools, how can we approach answering this question? And through generation against these tools and the context they provide, return actions and insights that one of these tools in a microcosm, one of these accelerated paths, might not have been able to provide. So you see the two different paths. They unify back at the tools they utilize. As you can see, there's maybe a text-to-SQL tool, a retrieval tool. Maybe there are multiple of these tools. One is against a transactional database that we need to do quick lookups against to make sure we can even change, right? One might be a retrieval tool against a system of knowledge bases for HR. One might be another system that's a knowledge base for procurement or finance or any of these other domains. And those key systems with different retrieval tools might work in slightly different ways to be optimized for their business domain. Additionally, we can think about the actions that these systems might have to take in a empowered generative AI system where they can, send an email, update a database, change records, send a Teams message, that sort of thing, right? It's the difference with an accelerated path where people have seen these systems, know the workflow that people are trying to solve, and quickly being able to address them in an order of tool invocations versus dynamic agent reasoning to call upon these tools to solve this question or request for an action in that dynamic way. And at the end of this system, we would say, let's return all of these results to the user and maybe even expose the logic and tools that it's invoking, provided there's good governance around all of that, right? And log those results to some sort of inference table like on Databricks, where we have those that we can then compare and evaluate this overall system performance, both offline, i.e. testing new variants of the system, testing new tools, and online, where we are assessing as it exists in QA or production. Hey, is this providing high quality answers? Are customers satisfied? Are users satisfied? Are they getting the insights they are looking for? And if not, being able to opine on why and give feedback to the system, is this good or bad, and why wouldn't it be? Now, this is a very brief overview of the core concepts around compound AI systems. What Robert's going to do is he's going to expand on this particular left side of the chart or diagram, the agent reasoning mechanisms and the tools that you can connect these agents to be successful. This demo won't go into too much of those accelerated paths, but when you're thinking about these system designs, you might define, hey, use this tool, that tool, to make sure you get really good responsiveness and capture specific workflows in these deterministic ways. Any questions, team, before we proceed to the next phase where we review Robert's demo? Awesome. So I'm going to hand this on over to Robert. He's going to introduce the concept of agents, double click on all of that, and then show us his Agent Studio demo. Oh, that was an instant cutover. Nicely done. You are muted.
I'm back.
Now you're good. Yep.
Thank you, Arthur, for all that introduction. I'm not going to to go too in depth here on what an agent is after that explanation, but I do want to at least create a picture here of how an agent might interact. What you see is the user doesn't interact directly with the LLM. Instead, it's going through this agent service in the middle. And what that does is it handles communication between the user, the tools, and the LLM. So when a user submits a prompt, what the agent does is it passes that prompt through to the LLM, but it augments it with a list of tools. So it might send through the user's question. In this scenario, what is our EBITDA for the current year? But it also supplies to it, hey, I have in my wheelhouse the ability to look up information against the business glossary, along with the description of what that might look like. And then I have the ability to execute information against the database with certain methods, like this is how I can lift tables, this is how I get table definitions, and then this is how I can execute SQL. And so the LLM takes all that information and it charts a path to the answer from that user. And so in this situation, it goes, okay, first I need information around EBITDA. And so it looks up information from the business glossary on EBITDA. So it tells the agent, hey, I want to go and look up this information. The agent is the one that actually performs that task of going and getting that data. But all it does is turn around and supply it back to the LLM. So the LLM now has a chat history forming where it has the original question, the list of tools available to it, and now the information on the business glossary. Then it goes back to the agent and says, okay, what tables do I have available to query? The agent performs that lookup, supplies it back to the LLM. Now the LLM then asks for certain table definitions. Maybe it recognizes 2 or 3 tables that are going to be helpful for it. And so it goes and it gets that information. And then it supplies that once again to the LLM. And the LLM then is able to generate SQL that it feels will get the answer. The agent executes that SQL against the database, getting the data set and returning it to the LLM. Now the LLM has a full context of all the information that it needs to be able to answer that original user question. And it can summarize those results and feed an answer back to the agent. The agent then, instead of executing a tool, supplies that information to the user. So the user has a single prompt and gets a single response. But in the background, the LLM is chatting back and forth with the agent, gathering information, and then getting to an answer. The benefits here is you can use the LLM as a brain, let the LLM decide what actions to take. So it's very good in a conversational type nature when you may or may not want to execute certain tasks, let the LLM decide that. The cons are it does require an LLM with strong reasoning capabilities. So the number of models that you can use with this are somewhat limited, but it does open up your options along the lines of capabilities in a conversational manner. So with that said, I'm going to hop on over. Let's see here, we're going to move my bar. Hop on over to the chatbot. So this is a sample chat application that I built with an agent. What you see here is a chatbot that has two main tools available to it. It actually has 2 sort of lookup tools. One is the ability to search for APIs in Databricks. And so it can search and find a listing of APIs, the top 10 results, so to speak, on Databricks API endpoints. And then it can look up specific documentation around a specific API endpoint. So it can say, okay, now that I found this API endpoint that's of interest to me, I want documentation for that endpoint and retrieve that documentation. And then it also has a second set of tools, or one tool in particular, that allows it to execute against an API endpoint. So if it supplies the payload, the endpoint, and the post method, so whether or not you're posting, getting, or whatever the HTTP method, it then executes that information and returns the response to the LLM. So between these 3 tools, the LLM is able to look up information about the API, and then it's able to execute against that API. That information lookup is being driven by a RAG or a vector search database, sort of like what you would build in a typical RAG solution, and downloaded the API documentation off the internet, going through and storing that into a Delta table, and then creating vector search on top of that. I can walk through the backend solution for that as we get through this. But anyway, so I have sort of a question already written up. I have a job with the name demos, DLT, and at Robert Mosley. Can you help me find it and start it for me? Before I do that, though, I want to show you what happens if I just say hello to the chatbot. So it comes back and says, hello, can I assist you today? And I give us a special sneak peek into what's happening in the back end by being able to click on the JSON and seeing the full conversation history here. So you can see my system prompt, and those are instruction sets that the user is not aware of. And then this is me saying hello, and then this is the bot responding to it. As you can see, there's no tool calls, no actions that are taking place. And so now I'm going to send that message through where I want it to be able to execute this task for me. And so immediately you can see that it's thinking, it's going through the process. And then we're going to see what its response is after it's finished going through the steps. And not only will we see the response here, but we'll be able to step through and see all the actions that the LLM took on its journey to get there. And because it is chatty in the background, sometimes it can take a little bit of time, a little bit of latency. As you see, it did find that job, and then it took the action for it. First things first, I want to step back into Databricks, and we're going to go take a look at that. So we got job runs over here. We can get it to load. All right, and I'm going to look at my job runs. So we see it, right? This job is currently running. As you can tell, I've also tested it. I'm going to click over into that job. We see that it's running. In fact, I don't really want it to run. So I'm going to come back over here. And I'm going to say, cancel that job run. And I'm telling it now to cancel the run. And we're going to see what it does. So what we've seen here is the agent was able to go and start that. We're going to walk through here in a second and see the full action around that. But you can see here now it tells me that job has been canceled. I'm going to step back into this, and we see that indeed the job was canceled. So we're gonna see what happened behind the scenes, not just what the user witnesses. But when I ask it, there's a job with this. What it immediately does is it looks for a list jobs API. So it's doing a search. And you can see here, I told you the top 10 search results are returned to the LLM. So you see list jobs is the first one that comes back. List job runs, a bunch of others. It quickly identifies that list jobs is in fact the job that it's looking for, or the API endpoint that it's looking for. So then it executes, hey, get me the documentation for this, retrieve API doc for list jobs. And then this is the full documentation for listing API jobs. As you see, I have an opportunity here to optimize this because there are a lot of text in that documentation endpoint. And so I'm returning quite a bit to it. But it does learn from that how to go and search for it. As you see, it learns how it can supply a name and search for that name and get information about that job. So it executes that command. And then the result comes back and it gets a job ID, which ends up being the critical element for the next step. And then what it did from it's deciding now it needs to run the job. So it's searching for the API around that. Once again, the search results come back. The very first search result is trigger a new job run. There also create a new job, create trigger a one-time run. It understands that what it's really wanting to do is to trigger a new job run. It goes and it retrieves the documentation around that. This documentation is much shorter. It then says, okay, I want to execute this. And it's running the job based on the documentation that it saw up above. And we see we get a run ID back. So now the LLM has successfully executed this job. And then what it does, it summarizes that result for us. And we get the run ID for this job is this, telling us, hey, I'm done. And that's great. We went in, we saw that it indeed had executed and was running. And then this is me coming back and saying, hey, cancel that job run. So now it's going, okay, I need to search for cancel job run. It finds cancel a run, cancel all runs of a job, delete a job run. But it identifies that cancel a run is the task that it wants to pursue. It looks up the documentation around that. This is the shortest documentation, pretty quick and easy there. And then it comes back and executes that call, telling what run ID to execute. And then it gets a successful message back. So then it tells me, hey, I've successfully canceled this job. So the capabilities here, providing it with raw access to be able to look up API documentation and then to execute against it. As you can see, the reasoning ability of this model, and I'm using GPT-4, so I'm using the latest from OpenAI, it is able to navigate those steps pretty significantly. I could simplify it, particularly for this type of operation, if I'm trying to build a solution for an engineer, where I give it a tool to look up jobs, give it a tool to execute jobs, give it a tool to cancel jobs. That would simplify it and allow a less performant model to be able to navigate some of these exact same steps. For this exercise, I really like demonstrating this because it shows just how capable it really is and how some of the more fundamental tools that you provide it really open up. Because of the capabilities here, you can see you have the ability to go so far as to look up models, maybe create models, maybe perform certain runs. You could execute SQL against a data warehouse, all from these exact same tool sets, because all that stuff is documented in our API doc. So that is the summary of our action. What you're going to say is, okay, now something like this must be really hard to build. And so I'm going to show you guys the steps and how to build something like this. So this is the other UI that exists in this Agent Studio build out. And what you see here is just the framework from which to go ahead and create your model. I'm gonna type in a model name. This is the 3 namespaces that it's anticipating. So catalog, schema, and then model name. And so I'm going to call this the Databricks API demo. My provider for this is going to be OpenAI. I could come in here and give it Databricks and then specify like the Mixtral model or Llama 2. I've created some shortcuts that point to those, but you can also just provide the Databricks endpoint name. It's really like Databricks -Mixtral -8x7b or something like that. And I'll go to the Databricks model on the model serving side. On the OpenAI, I've also created a shortcut that I just type in 4 and it uses the latest model from 4. On description, you just provide it with a description. To save you guys from watching me type through all this stuff, I've sort of built this out a little bit on the side. So I'm just going to grab some of the information that I put out here. Looks like I kept it pretty bare bones for this one. So I'm going to do that. And then the instruction. So the instruction is probably the most important aspect of this, or one of the most important aspects of this, because the instruction is what is provided to the LLM in that system prompt. And this is really where prompt engineering can be a critical tool. So, you're a Databricks agent capable of executing calls. One of the things I learned when testing this is that sometimes it likes to assume it knows how to use the API, even if the API hasn't looked up the documentation for the API, and then it makes a mistake, and then it has to sort of double back. So what I'm going to do is I'm actually going to provide an extra instruction set here. Do not execute an API call before looking documentation for that endpoint. Especially with something like the Databricks API, because it's publicly available, the model has been trained on the Databricks API. So it's seen this information before. It doesn't always get it right. And if you ask it questions without having the reference there, sometimes it misremembers, or it's using old documentation or something like that. So we want to make sure that it's always referencing the API documentation before it actually tries to execute it. So I'm going to add that little piece there. So that's an example of some prompt engineering that you can do. And then I have some basic tools that exist out here. You have text-to-SQL that uses Unity Catalog, where you would specify a catalog in a schema, and also a warehouse ID that you're going to go against. And this is capable of searching Unity Catalog, finding the tables that are inside that schema, getting table definitions for those tables, even retrieving sample data from those tables, and then executing SQL. And so the LLM is capable of navigating a lot of that and then creating SQL to be executed. I have a Python executor code here. So if it wants to generate Python scripts, it can then execute them, and it gets loaded into a notebook and executed in Databricks. Vector search retriever. So this would allow you to use any vector search endpoint and index name. And then you can also provide some extra instructions in there that it learns, so it knows what the vector database is for. And this is used to be able to provide vector search lookups. My very first version of this API tool used that one. The two tools I'm going to use for this are the executor and the API search. So I'm going to add this executor tool. What you'll see first off is this is the YAML that's being built out. This is a representation of the agent. This tool does not require any parameters. It just basically assumes that you're working off the API for the current workspace, and it uses that workspace's APIs as what it's going to go against. And then I'm also going to add a search. So one of the key things with this is the ability to add multiple tools. So I added this search, and you can see here that it is looking for two different parameters. So a vector search endpoint and an index name. So once again, I have those already captured over here. This is, oops, be helpful if I didn't delete it. And I'm going to come in here and paste that in. And then over here, get my index name. So this is a vector search index. If you're familiar with Databricks vector search, you're going to know what that is. All right. So that is our creation there. As you can see, these are all sort of tied together. My plan is to make this UI a little bit prettier, capture those parameters in the UI instead of having it editing the YAML. But once you've got your agent where you want it, all you got to do is click this deploy button, and it fires off. And you see, once again, I'm still learning Gradio and how to activate things. So it doesn't say anything to you, and you're like, well, what's going on? So in the background, what it's done is it's actually created this notebook. The Databricks API demo. You see it has everything that you need, including the tools for executor and search. It brings all that in. It builds out all the install requirements you had, like the vector search Databricks there, based on the tool that you selected. And it creates the code for building the model, logging it, registering it. So you see that it'll be registered in Unity Catalog, and then creating the vector search endpoint. It also captures the YAML that we generated out there. And so it's over here in this YAML file. If we go into job runs, we see that it's running. It's currently going. It's probably going to be completed soon. So in the background, it's executed that notebook, and it's running that notebook for all of our tasks. So we see our model was registered. And then, oh, sorry, it hadn't been registered yet. It had been logged, created version 1 of this model. So now it's been registered. And now the endpoint is being spun up. So if we're to go over into model serving, we see the Databricks API demo is being spun up right now. This will take 10 or 15 minutes for it to be created. The inference table is created for it. It's running, and this will be up and ready in about 10 or 15 minutes. If I step over into the catalog, I don't know how much I'm supposed to hide all this. Nobody saw that, I'm sure.
Exactly.
step into this. Yep. And so, of course, it all showed back up. But so you'll see over here, the Databricks API demo model was created with our version set to alias of prod. In addition to that, on our tables, our Databricks agent demo, Databricks API agent demo payload. So this is the inference table that was created. If you wanted an example of an inference table that already exists, you can come over here and let me try to get this. There we go. I'm going to click that. You can see the calls that we just made should be captured out here. And so you have information that was logged. So this is 229, so 301 would be our date. Yeah, so these would be our calls that we were making just a second ago. You can see our hello message. You can see I had tried a hello message earlier. So you see all the inputs, you see all the responses, and all that stuff logged. So you have your conversational history now, and you can use this for monitoring or evaluating, or for even fine tuning and stuff later on down the road if that's what you're doing. I will warn it's against terms of service to use OpenAI's outputs for fine tuning. Got to provide that caveat. But if you're using other models or whatever for this, you can use those models outputs. But anyway, so that is that solution there. The only other thing I'll probably show is back on the catalog. Is on I wanted to show that BS index. So this is the data set that I built my vector search on. As you can see, it's Databricks documentation, publicly accessible. This is after I've done some data engineering work. And when it comes to vector search, it's purely data engineering. You ingest text data, you parse it apart, and you create your data sets. And then all you do is you push that data set to a vector search endpoint and creates the vector search index, which is what you then are doing all your similarity searches against. And so all you got to do is provide this information, that DB demos VS endpoint on the serving endpoint, and then the table, and you're able to do your tool lookups and everything, and the LLM knows how to navigate that. Anyway, that's it for me. Curious if anybody has any questions.
Yeah, really appreciate your time today, Robert and team. Like, as you saw, very beginning, we said, wow, let's understand how we build these compound systems that are a lot of effort, right? Then we recognize, okay, what do we do about agents, right? And how do we approach this problem? How can we make this very tool-driven, multi-dimensional space something that's much simpler to approach? You can see the outcomes of that through deployed models from Robert's agent in the beginning of that example. And at the end, you can see all of these pieces and how they come together in a really seamless way where it doesn't take days and days and days to make. It materializes really quickly. You can add tools to it. So in future sessions, we're going to be talking about deployment and how you set up the Agent Studio the first time, and then how you build out each of these tools for common GenAI scenarios. So really appreciate everyone's time today. Looking forward to the next sessions. Thank you so much. Thank you, Robert, and have a great day.
Okay. So if anybody has any questions, I'm happy to field them.
So not a question, I would say, but this is Brijendra. So this really loved the demo. So thanks for sharing all the information and all the details. Yeah, so we're definitely looking forward to how to build one on our own. So yeah, thank you.
Yeah. So we are gonna do our next video is gonna be around deployment. We've actually already recorded it, so we'll get that out along with this. And to your point, as far as building, the only other thing that you need to do development wise is potentially build more tools. And I hope to build out additional tools and put them out there. But beyond that, like it's completely extensible. You don't have to wait on me to build anything. Tools can be built out. They're just libraries in the code. Andrew can attest to that. And they can be assimilated into the program very quickly and easily. And so we're going to be releasing videos around that too. What does it take to build a new tool and get it incorporated, that kind of thing.
Awesome. Exciting. Well, thanks, Robert. This was awesome. Look forward
Yep.
to more of them, and guess I'll catch you later today.
Okay.